Assalamualaikum and thank you, respected session co-chair and other authors to give me the opportunity to represent my paper. A faithful dog is all you need. So my presentation captures these three scopes that are flashed on the screen. Basically, image segmentation in image processing is a technique which separates the object from the images by taking the image features into consideration. There are several applications of image segmentation techniques. Those are flashed on the screen, like pseudo coloring, medical object visualization, 3D reconstruction, object motion tracking, and so on. There are several image segmentation techniques. Those are discontinuity-based techniques, region-based, territorial-based, and active control-based model. Discontinuity-based technique basically seeks the discontinuity of the images, like points, lines, and edges. In region-based models, relies on the fact that the neighborhood with pixels within a region should have similar values. Under region-based segmentation technique, there comes region growing, region merging, and region splitting techniques. Territorial-based model is one of the most simplest image segmentation model because here the image is segmented out depending on the threshold value. It binarized image like Ursus method. Active control-based model is also a popular model that is getting popular day by day. Here image is segmented by curve evolution. They are of several types: region-based, test-based, and hybrid. Active control-based model was first proposed by Kass et al., also known as snake model, because they are called snakes because when the curve is evolving during the process, it looks like a snake. Here the curve, which is initialized, evolves in order to minimize the energy function by gradient descent method. They are of two types: edge-based and region-based. Energy of the curve is measured by iterative process. The curve solution drops to zero on the boundary of the object. As a small animation, that's how the curve is evolving around the object. Fitted to the object. The active control models are based for their self-adaptability in their pursuit of a low energy state. They can be used to track moving objects. They require less computational cost. They require no training data set like deep learning models. In active control model, curves are the main protagonist. It is curve which evolves through the process in order to minimize the energy function. These curves are 2D function, 2D closed loop function, but the evolution of a 2D function is quite a bit complex to represent it mathematically. So we increase the dimension. We all know that the level set of a 3D function is a 2D function. So we implement the 2D function via the 3D function, and you can see it in this video that how a 3D function is representing those 2D functions, those curves. Yeah, the 3D function is going up and down while the curve is evolving and making new shapes. You can see it. We just cut through the 3D function and to a specific surface, and we get those curves shape. Energy function is another important term in active control-based model. It is energy function that is behind the evolution of the curve. The curve evolves in order to minimize the energy function. The energy function is divided into two categories: energy of the image, E image, and the other one is energy of the contour, E contour. The internal energy of the inter contour or E contour reveals the curve's flexibility, smoothness of the curve, and the elasticity. We all want that the curve tightly fits to the boundary of the object, and for that reason, elasticity is an important term here. And E-image is the measure of how well the contour latches onto the edges. Basically, this term comes from the image information. Active control-based segmentation are of mainly two types: edge-based model and the other one is region-based model. Edge-based model utilizes the edge information, and on the other hand, region-based model utilizes the regional statistical information, both of having their own pros and cons. Edge-based models are easier to implement, but on the other hand, it performs really bad in the images with weak edges. Chan-based model is a region-based model that was proposed by Tony Chan and Lumita Vase at 2001. It uses global information of the image as they are utilizing global information, so it is unable to segment the intensity in homogeneous images. RSF is also another region-based model which solves the issue of CV model. Here, it basically calculates local averages inside a Gaussian window. So here we can see the energy function of the RSF model. It is a quadratic error between the approximated average image and the real images. It has initial robustness issue, but as it is dealing with local information, so it is immune to inhomogeneous. But here also the curve C will start in local minima. So to solve this issue, there comes the log RSF. Log RSF is a hybrid model which is a fusion of an age-based model, log, and the region-based energy RSF. Here, the age-based model is designed by LOG or Laplacian of Gaussian operator, which is a second-order age-detector operator. Log is here parabolic and RSF is a quadratic term. Log is meant RSF to get in image in less order iteration. Log is also sensitive to noisy images, so it has some issues. Limitation of business efficiency are less initialization, robustness, less noise tolerances, intensity homogeneous image, and time efficiency also. So we proposed a model which is a combination of region-based model energy and weighted and age-based energy function equal to dog int. Here, our model results in an optimized dog image. Basically, dog is an all age detector operator like log, but dog is less noisy than log, but still it is noisy. So we optimize it via gradient-based optimization in our energy function. And here you can see the difference between normal dog and the optimized dog. The normal dog is much more noisy than the normal dog. The optimized dog is much less noisy than the normal dog. So our proposed model solves the issue of starting at local minima also. Our optimized dog is less noisy than the log as well as dog. It requires less computational cost, more tunable. To guide the curve in the right direction, we use entropy also as weight along with the dog energy. So finally, by gradient descent method, energy function becomes the following. In this paper, we have developed an optimized dog age-based energy function. Use the entropy of the image as weight to dog energy. We have also integrated the age-based energy functional informational framework and level set formulation. Combine the age-based function with the region-based model. We have used entropy of the image so that it can guide the contour towards the edge of the images. We have also added parameters to finely tune the age-based and region-based model. We have tested on Wiseman and Berkeley datasets. In experimental design parameters, we have taken nature in experiment. We have taken natural, synthetic, and medical images with noise and intensity inhomogeneity, initialization, robustness, noise tolerance, and dictation number, and types are evaluated during the experiment. There's a small description of parameters. During the experiment, we have noted down some parameter values which are flashed on the screen. We tested the initialization robustness in these images for these images, and we can see that our model is outperforming the other two models. Our models results are on the first row, and in the second and third row are the results of logarithm and IC. There is another initialization robustness test, where we can see that our model is outperforming the other two models also, which is expected. For noise tolerance test, we have taken an intensity inhomogeneous noisy image, and in here we can see that our model is doing a good job. During the experiment, we have taken down some experimental results value, and we can observe that our proposed model requires less iteration number and less time. We have also did the whole experiment for some natural images also, and you can see that our model is also doing a decent job here. The experiments for natural images shown in a table. Here you can see that our proposed model requires less iteration number and less time and higher DSC. DSC is a score. Higher the score, better the segmentation quality. That's estimated index basically. Here, in conclusion, we have proposed a new hybrid ACM to segment intensity in homogeneous and noisy natural images. Use dog operator as age-based function. Gradient-based optimization of the age-based function is done. Added entropy as weight to the age-based energy functional. Our experiment shows proposed models have higher initialization robustness and higher noise tolerance. The edge-based energy function augments the RSF energy function to get minimized in less iteration. Execution time and iteration number are less for the proposed model. In future work, we would like to improve the performance of the model, including more edge and region-based features, extend its performance analysis considering different imaging applications. Here are some references which we have taken in making the slide. Thank you.